The gimmick for this opening is that it's lucky number 7, you've won the jackpot. I'm wearing a sparkly gold shirt. And in all seriousness, if you have made it this far, incredible. Well done. Can't believe that's actually happening. If that is happening in the future. Somebody's watching this all the way through. You really should feel proud of yourself. It's dense material, it's very complex, and it's not actually easy for anyone besides like child prodigies, savants. It really is just complicated shit. So, well done. Now, input and output. So there are several ways to present the output of a program. Data can be printed in a human-readable form or written to a file for future use. This chapter will discuss just some of the possibilities. Starting with fancier output formatting. So far, we have encountered 2 ways of writing values, expression statements and the print function. A third way is using the right method of file objects. The standard output file can be referenced as sys.stdout, sys.stdout, system.standardoutput. See the library reference for more information on this and anything else, because it's the library reference. Often, you will want more control over the formatting of your output than simply printing space-separated values. Thankfully, there are several ways to format output. To use formatted string literals, begin a string with F or F, lowercase or uppercase, before the opening quotation mark or triple quotation mark, which is, remember what you use if the string is going to be multi-line, use 3 quotation marks. Inside this string, you can write a Python expression between the opening curly bracket or brace and the closing curly bracket or brace. From here on out, I'll call it the curly brace. Characters that can refer to variables or literal values. So say we've got a variable, which we define year. We set equal to the value, the integer 2016. Then we define a variable event, which we set equal to the value of the string referendum. Now here we have a string preceded immediately, uncomfortably close, by the single letter F, which means it's a formatted string literal. And the string says results of the, and then inside curly brackets, curly braces, I even said I would call them curly braces. Inside those it says year, and in another curly brace statement it says event. And the output is results of the 2016 referendum, because this is, as the curly braces inside the string indicate a replacement field that will, upon output, be replaced with whatever you define inside them. And in this case, the variable names year and event will output the values respectively of those 2 variables in place of the replacement fields indicated by the curly braces. The string.format method of strings requires more manual effort. You'll still use the opening and closing curly braces to mark where a variable will be substituted and can provide detailed formatting directives, but you'll also need to provide the information to be formatted. So here in this example, we set the value of the variable yes_votes equal to 42_572_654. Set the value of the variable no_votes equal to 43_132_495. We set the value of a variable percentage equal to the result of dividing yes votes by the sum of yes votes and no votes. And we are here using the string.format method. Rather than putting an F just up in front of the string, you can define the string and follow it with .format and pass in as arguments here what you want to be inside these. But you can also add more detailed formatting directives, which is what these characters in here are specifying how they want the input to be presented on the final output. And I'm going to be honest with you, I'm not 100% sure what all of these mean, but it's not really that important at this point. But I mean, I know that like this is saying display it as a percentage that goes to 2 decimal places and is at least 2 characters wide. even if they have to be zeros. Make it there's a minimum field width. I'm pretty sure that this is the minimum field width as well, 9 characters, but actually not 100% sure what those aspects mean, but whatever they mean, they turn yes votes in the first replacement field and percentage in the second replacement field get outputted like this. Okay. Finally, you can do all the string handling yourself. Don't fucking make excuses. By using string slicing and concatenation operations to create any layout you can imagine. And remember, concatenate means to chain together. The string type has some methods that perform useful operations for padding strings to a given column width. Padding, like adding just extra empty space around something to fill out a space, like it's a visual term. When you don't need fancy output, we just want a quick display of some variables for debugging purposes. Come on, you can convert any value to a string with the repr, R-E-P-R, which means representation, or str string functions. Now, the string function is meant to turn representations of values which are fairly human, is meant to return representations of values which are fairly human readable, while representation is meant to generate representations which can be read by the interpreter or will force a syntax error if there is no equivalent syntax. And so, like, the output of the representation function should theoretically be, you should be able to pass that into the evaluate function, and the output of that would give you back whatever your original input was that you put into the representation function. So it's the priority isn't like with the string function, it's just to create a human readable output, whereas the representation is like a more literal and more computer-y output. It's a subtle distinction that I don't fully understand yet, but as I understand, that's what it is. For objects which don't have a particular representation for human consumption, string will return the same value as representation. Many values, such as numbers or structures like lists and dictionaries, have the same representation using either function. Strings, in particular, have 2 distinct representations. Some examples include, say we had a simple little old variable s that we set to the value of this string hello world. If we pass the variable s as an argument into the string function, the output will be exactly the same as the input, right? And the representation of s will be very, very close, but it'll give us like a string of the string in this case, because it will show us that we included single quotes in our original input. You see what I mean? And it puts quotes around that. And if we pass the result of dividing 1 by 7 into string, then it will return the float representation of that, right? Because remember, division always returns a float, even if it's a whole number in Python. It's not a whole number in this case, but I'm just reminding you. Now say we set the value of the variable x equal to the product of 10 times 3.25. We set the value of the variable y equal to the product of 200 times 200. And we set the value of the variable s, we updated it, to be the string the value of x is, space, concatenated with the representation of x passed into the repr function, concatenated with the string comma, space, and y is, concatenated with the repr of y, concatenated with ellipses dots in the form of a string. And then if we pass all of that nonsense into the print function, we get the value of x is 32.5 and y is 40,000. It's kind of interesting, I'm not sure. And now the comment reads, the repr of a string adds string quotes and backslashes. So say we set the value of the variable hello equal to the string hello world and then a new line character, backslash in. Now, wait a second. Oh yeah, and now we make a new variable called hellos, which we set equal to the output of passing this variable hello into the function, into the representation function. If we then print this variable, what we get is actually hello world and the backslash and n that we originally added. It doesn't read that and format it as a new line. It gives us literally what we wrote in there. And even though it's being passed in, the print function is doing this because we've done this. Now, the argument to representation may be any Python object. We pass in any Python object. I think that's clear. The string module contains a template class that offers yet another way to substitute values into strings, using placeholders like $x and replacing them with values from a dictionary, but offers much less control of the formatting. Formatted string literals. I guess we're going to deep dive in this thing. Okay. Also called f-strings for short. Let you include the value of Python expressions inside a string by prefixing the string with f or f, lowercase or uppercase, and writing expressions as expression inside curly braces. An optional format specifier can follow the expression. An optional format specifier can follow the expression. This allows greater control over how the value is formatted. The following example rounds pi to 3 places after the decimal. First, we would have to import math, the math module, but then we could say print this f string, which states the value of pi is approximately, and then inside our replacement field, indicated by the curly braces here, math.pi:.3f. And this is what it will produce, 3.142. Now, passing an integer after the colon will cause that field to be a minimum number of characters wide. This is useful for making columns line up. So for instance, say we define a variable called table as equaling a dictionary, and remember, because here the curly braces don't always just indicate replacement fields. Of course, here's just a dictionary. Dictionary with the key value pairs shared and 4127, jack and 4198, and decab and 7678. Now, we start a for loop that says for name and phone in table with the items method, making it you capable of iterating through the key value pairs as whole units. At each step along that iteration, print an f string which contains the variable name and the variable phone, which is, because of this for loop, is going to mean, name here and then name, phone, and then phone, the phone. And then this :10 is saying that no matter how many characters, if it's only just a 2-letter name, you will still fill up the rest of a total of 10 characters wide space. So it will fill it in with white space here to make up the rest of that 10, meaning that you have these aligned, consistent columns. And in this case, also, we've got first the width, the minimum width, and then the letter D. And I got no idea what that means. Just a second. Yeah, I'm still not sure, but I'm not going to spend that much time finding this one specific thing. You can look up, all of the specific different formatting options that you've got in f-strings. I think the point to focus on here is just knowing what they are in general. Bada bing, but I think it has something to do with making it a number. Other modifiers can be used to convert the value before it is formatted. So say $A or bang A applies ASCII, bang S applies string, and bang R applies the representation. So that's very interesting. You can use just this little syntax to make it as like you're passing it into these various functions. So say we've got a variable animals, we set equal to the value of the string eels, and we pass into the print function the f string of a string stating my hovercraft is full of, and then a replacement field which calls this variable animals. This will of course print my hovercraft is full of eels. But if we did the exact same thing except immediately after the variable name stated in the replacement field, we wrote bang R, then we would get the result of passing that variable into the representation function, meaning that our output would include the single quotes included in the original input defining that variable. So the equal specifier can be used to expand an expression to the text of the expression, an equal sign, then the representation of the evaluated expression. Interesting. Let's take a look at that. So say we got bugs equal in roaches. Count equals the integer of 13. And area equals the string living room. Now if we printed the f string, debugging, then in one replacement field, the variable bugs followed by an equal sign, in a second replacement field, the variable count followed by an equal sign, and in a third replacement field, the variable area followed by an equal sign, what we would get is debugging bugs equals roaches. The name of the variable equals the value set to it. Count equals the name of the variable and the value set to it. And area equals, you see the pattern. Now see self-documenting expressions for more information on the equal specifier. For a reference on these format specifications, see the reference guide for the format specification mini language. The string format method. So basic usage of the string.format method looks like this. Say you could print the string, we are the opening and closing curly braces with nothing inside, who say opening and closing curly braces with nothing inside, dot format, and then passed in as arguments, as positional arguments, the two strings which you wish to be outputted in these replacement fields defined by the curly braces. They will of course be put in the order in which they appear in the parenthetical statement following the format method. They're positional arguments. So that would output we are the knights who say neat. The brackets and characters within them, called format fields. What? I could have sworn replacement fields was the legitimate term. Are replaced with the objects passed into the string.format method. A number in the brackets can be used to refer to the position of the object passed into the string.format method. So, say if we said print, and inside our format fields, we have 0 and 1, respectively, dot format, and then the arguments spam and eggs, then this would produce spam and eggs. And if we reversed this, and the first format field said 1, and the second format field said 0, then this would produce eggs and spam. Because it's like looking up something at the index in a list, except your collection is just the arguments passed in here. So 0 is here and 1 is here. If keyword arguments are used in the string.format method, their values are referred to by using the name of the argument. So say, print in the string this, and in a format field food is, in a format field in which adjective is written, dot format, and then passed in as arguments to that format method, we have these values which we have explicitly defined with keywords. Food equals this string, adjective equals this string, then you can see where this is going, right? This spam is absolutely horrible. You know that the word spam, like email spam, like internet spam, that it originated from nerds talking about this fucking Monty Python skit too much on like old message boards? Look it up. shit is so dorky. Positional and keyword arguments can be arbitrarily combined. You can say have a format field that says 0, another format field that says 1, and a format field that has a keyword in it, and it'll all figure it out, as long as, of course, you have the keyword stated here set explicitly to one of the values in your arguments. You couldn't just put other and hope it figured that one out. If you have a really long format string that you just don't want to split up, it would be nice if you could reference the variables to be formatted by name instead of by position. This can be done by simply passing the dict and using square brackets to access the keys. So we've got this variable table, which we have set equal to this dictionary containing 3 key value pairs. Assured 4127, Jack 4198, decab 8637678. And we're using the dot format method, and as argument we've just passed in the whole thing, table. And since we passed in the whole thing, though, what we can do is look for the 0 at Jack, or the Jack spot of the 0 spot in the arguments. And these are all going to be 0 because there's only one argument passed in. So 0 is always referring to the whole table. Look at that table, and look at the spot in that table labeled Jack. Okay, and then, yeah, it must be something about numbers. And then the number is the value associated with Jack. And then look at the key assured in the thing at 0 in our argument. Look at the key decab within the thing passed in at position 0 in the arguments passed into dot format. And this will produce this. Bada bing, bada boom. The strings followed by the values associated with the thing at this item in the thing at this spot in the arguments. This could also be done by passing the table dictionary as keyword arguments with the star star notation. So say we have the exact same table. We could pass in the whole table as argument, but unpacked, right? That's what that means, what that's called. And then we don't have to start by checking at 0 in the argument each time. We can just refer directly to the keys, and the rest is the exact same. This is particularly useful in combination with the built-in function vars, which returns a dictionary containing all local variables, probably pronounced vars more commonly. As an example, the following lines produce a tidily aligned set of columns, giving integers and their squares and cubes. For x in range 1, 11, from 1 to 10, at each step of the way, print the dot format method with this passed in, x, these operations on the things found at each step along this for loop, which is just equal to the thing times itself, the thing times itself times itself. And 0 and 2, see, and this is the width, right? Hold up. So yeah, that number is indicating the minimum width, like the spaces, imagine them emanating out toward the left, as it were, because they're positioned here. And we'll get these nice, lovely, see, this column, everything is exactly 2 characters wide. This column is exactly 3 always. This one's always 4, right? And this is what we get. The result of these operations being applied in that manner. For a complete overview of string formatting with string.format, see format string syntax. Manual string formatting. Now here's the same table of squares and cubes formatted manually. For x in range 1 to 11, print the representation of x dot right justified with minimum width 2, followed by the representation of multiplying x by itself, make it right justified with a minimum width of 3, use white space as the sort of end character. Note the use of end on the previous line. And print representation of x times x times x, right justified with a minimum width of 4. That's how we would get there's another way to get the exact same output. Notice that the one space between each column was added by the way print works. It always adds spaces between its arguments. So the string.rjust method of string objects right justifies a string in a field of a given width by padding it with spaces on the left. There are similar methods, string.leftJustified and string.center. If you're not familiar with those terms, I mean, think of any word processor, like when you select the lines that are all lined up on the left, or the lines that line up on the right, or where it's perfectly symmetrical. That's what justify means in this case. It's a visual formatting term. These methods do not write anything. They just return a new string. If the input string is too long, they don't truncate it, but return it unchanged. This will mess up your column layout, but that's usually better than the alternative, which would be lying about a value. And folks, lying is wrong. If you really want truncation, you can always add a slice operation, as in x.ljust in slice, like this, okay? There is another method, string.zfill, which pads a numeric string on the left with zeros. It understands about plus and minus signs. So say we pass in the string 12.zfill 5. What we'll get is the string 12, except there's 3 zeros in front of it, making a total of 5 characters. Pass in the float, negative 3.14. .zfill 7 passed in as an argument. Then we get a 7-character long string padded with zeros to make up that space on the left, right? And we pass in 3.1415926535.zfill 5. What do we get? Because it's too long, we will get the entirety of 3.1415926535.9. Old string formatting. The modulo operator, modulo, can also be used for string formatting. Given string modulo values, instances of modulo in string are replaced with 0 or more elements of values. This operation is commonly known as string interpolation. For example, say we imported math from Turkey, and we print the string the value of pi is approximately modulo 5.3f dot modulo math.pi. We would get the value of pi is approximately pi to 3 decimal places, the max I guess it's, I mean, it just works. It's like a different way of doing the same thing as a format field. I'm not really grasping this. I mean, it's replacing, because there's a string modulo value, then it replaces instances of the modulo sign within the string with 0 or more elements of value. So that's, I can understand that. We've got 3 denoting that it's rounded, or it's truncated to the 3rd decimal point. No, it is rounded, isn't it? Yeah. Because that would be 3.14159. Still, I don't know. Not 100% sure. More information can be found in the printf style string formatting section. Now, reading and writing files. Open returns a file object and is most commonly used with 2 positional arguments and 1 keyword argument. For instance, say we used the open function with passed in as arguments file name, mode, and the keyword argument encoding equals none. We could set a variable f equal to the result of passing into the open function the arguments string work file, the string W, and the keyword argument encoding equals UTF-8. The first argument is a string containing the file name. The second argument is another string containing a few characters describing the way in which the file will be used. Mode can be R when the file will only be read mode. W for write in mode. An existing file with the same name will be erased if it's in that mode. Okay, and A opens the file for appending. Any data written to the file is automatically added to the end. Now, R plus opens the file for both reading and writing. I guess reading comes before writing. You should learn how to read before you try to write a book. So that's why it's not W plus for both of them. The mode argument is optional. R will be assumed if it's omitted. Normally, files are opened in text mode. That means you read and write strings from and to the file, which are encoded in a specific encoding. If encoding is not specified, the default is platform dependent. See open. Because UTF-8 is the modern de facto standard, encoding equals UTF-8 is recommended unless you know that you need to use a different encoding. By the way, UTF-8 is Unicode Transformation Format 8-bit, or at least I think it's like derived from that, is what I read. But everything's in UTF-8. It's pretty universal. Appending a B to the mode opens the file in binary mode. Binary mode data is read and written as bytes objects, and you cannot specify encoding when opening file in binary mode. In text mode, the default when reading is to convert platform-specific line endings, such as \n on Unix, \r\n on Windows, to just \n. When writing in text mode, the default is to convert occurrences of \n back to platform-specific line endings. This behind-the-scenes modification of file data is fine for text files, okay? But it will corrupt binary data like that in JPEG or exe files. So be very careful to use binary mode when reading and writing such files. I mean, come on. Why would you do that? It is good practice to use the with keyword when dealing with file objects. The advantage is that the file is properly closed after its suite finishes, even if an exception is raised at some point. Using with is also much shorter than writing equivalent try finally blocks. With, the result of passing into the open function the argument's work file, the encoding set to UTF-8, as F, read data, let's set the value of read data to f.read. Now we can check that the file has been automatically closed by checking f.closed. True. Now if you're not using the with keyword, then you should call f.close to close the file and immediately free up any system resources used by it. Warning! Calling f.write without using the with keyword or calling f.close might result in the arguments of f.write not being completely written to the disk even if the program exits successfully. Warning over. After a file object is closed, either by a with statement or by calling f.close, attempts to use the file object will automatically fail. So, say we f.closed, then we f.read, value error. I/O operation on closed file. It's closed. You just closed it. Methods of file objects. The rest of the examples in this section will assume that a file object called f has already been created. To read a file's contents, call file.read with size passed in, which reads some quantity of data and returns it as a string in text mode or bytes object in binary mode. Size is an optional numeric argument. When size is omitted or negative, the entire contents of the file will be read and returned. It's your problem if the file is twice as large as your machine's memory. Otherwise, at most, size characters in text mode or size bytes in binary mode are read and returned. And remember here, they're saying that you wouldn't actually write size, you would put in numbers. Okay, if the end of the file has been reached, f.read will return an empty string. So f.read with nothing passed in, this is the entire file \n. f.read with nothing passed in, empty string. Dang. Because it's already reached the end of the file. f.readLine reads a single line from the file. A new line character, \n, is left at the end of the string and is only omitted on the last line of the file if the file doesn't end in a new line. This makes the return value unambiguous. If f.readLine returns an empty string, you know the end of the file has been reached, while a blank line is represented by \n, a string containing only a single new line. Since you know that those aren't since you know that that's omitted at the last line, then if it's not even returning that, then you're at the end. So f.readLine, this is the first line of the file, new line character. Call it again, we get a second line of the file, a new line character. Call it a third time, because there's only 2 lines in the file, we return. For reading lines from a file, you can loop over the file object. This is memory efficient, it's fast, leads to simple code. For line in F, for thing in thing, print line followed by with using space at the end, right? This is the first line of the file, second line of the file. If you want to read all the lines of a file in a list, you can also use listf or f.readLines. So f.write string writes the contents of string to the file. The file that's, remember that f is just the random variable name that they chose, which I feel is a confusing choice on their part to say this our hypothetical file, we're just going to call it f in the thing about f strings. It's confusing. But we can call this, we'll just call it file fappy whatever .write with a string passed in. So jam.write with the string, this is a test \n passed in. If we type this and press enter in the interpreter, we will just get the number of characters in it. Other types of objects need to be converted, either to a string in text mode or a bytes object in binary mode, before writing them. So say we set the value of a variable value equal to a tuple containing the string, the answer, and the integer 42. Another Douglas Adams reference. I hope that guy doesn't mind turning in his grave. Okay, and we set the value of a variable s equal to the result of passing in value to the string, value being the name of this variable, right? Passing in this tuple to the string function, converts the tuple to a string. So if we then use file.write, passing in s, we get 18, the number of characters in the string produced by passing in the value of this variable value to the string function. f.tell returns an integer giving the file object's current position in the file represented as a number of bytes from the beginning of the file when in binary mode and an opaque number when in text mode. What? To change the file object's position, use f.seek with offset and whence passed in as argument. And if you're not very familiar with a little bit more archaic English, especially if the English is your second language, whence, like from whence did you come? How to define that? Whence? I can't think of a concise definition. Yeah, I guess that's it. It's from, whence just means from which or from where or from what place or source. A whence value. So the position is computed from adding offset to a reference point. The reference point is selected by the whence argument. That makes sense. That's from where it comes. That's from whence the rest of it comes. A whence value of 0 measures from the beginning of the file. You've come from where? I came from 0. Story of my life, man. 1 uses the current file position, and 2 uses the end of the file as a reference point. Whence can be omitted and defaults to 0 using the beginning of the file as the reference point. So if you don't specify from whence it comes, it will just assume it comes from the beginning. So say we set the value of this variable f equal to the result of passing in work file and rb plus, these two strings, to the open function. And then if we use the .write method on this variable f with b and this string of bullshit passed in this argument, then we get 16. It's the number of characters, right? f.seek 5 will go to the 6th byte in the file because that's still 0 indexed. So it's 0, 1, 2, 0, 1, 2, 3, 4, 5 would be the 6th byte. f.read at 1 will produce b and then with quotes around it, the 5. f.seek -3 and 2 passed in as arguments. This will go to the 3rd byte before the end. So again, it's just like looking up an index, looking up something in a list at the index. With negative numbers, it's how many from the end. And f.read 1, you see what's going on here. In text files, those opened without a b in the mode string only seeks relative to the beginning of the file are allowed. Only seeks relative to the beginning of the file are allowed. The exception being seeking to the very file end with seek 0, 2. And the only valid offset values are those returned from the f.tell or 0. Any other offset value produces undefined behavior. File objects have some additional methods, such as isatya and truncate, which are less frequently used. Consult the library reference for a complete guide to file objects. Saving structured data with JSON. Now I said it JSON because I think it's kind of funny. I think a lot of people probably say JSON. But strings can easily be written to and read from a file. Numbers take a bit more effort since the read method only returns strings, which will have to be passed to a function like int, the integer function, which takes a string like quote 123 quote and returns its numeric value 123. When you want to save more complex data types like nested lists and dictionaries, parsing and serializing by hand becomes complicated. Rather than having users constantly writing and debugging code to save complicated data types to files, Python allows you to use the popular data interchange format called JSON, JavaScript Object Notation. Sorry, get comfortable. A standard module, I have ADHD, called JSON can take Python data hierarchies and convert them to string representations. This process is called serializing. Reconstructing the data from the string representation is called deserializing. Between serializing and deserializing, the string representing the object may have been stored in a file or data, or sent over a network connection to some distant machine. Note: the JSON format is commonly used by modern applications to allow for data exchange. Many programmers are already familiar with it, which makes it a good choice for interoperability. Man, way to really throw some shade. Like, sorry, I'm new. If you have an object X, you can view its JSON string representation with a simple line of code. We can first import JSON. You can set the value of X equal to a list containing the values 1, a string simple, and a string list. Then you can use the .dumps method with X passed in as an argument or JSON.dumps, right? And it will produce the entire list as a string, including the brackets, the whole thing unformatted, Another variant of the dumps function well, it doesn't return it. You can view it, right? It's not printing the string in the same way, right? Another variant of the dumps function called dump simply serializes the object to a text file. So if f is a text file object open for writing, we can do this. json.dump xf. To decode the object again, if f is a binary file or text file object, remember, so if f is a text file object, you can use it like that. Again, I feel like it's confusing to do it like this. We can just call it, this could be file. But if f is a binary file or text file object which has been opened for reading, you can set the value of a variable equal to the result of using json.load with other variable passed in as argument. File. JSON files must be encoded in UTF-8. So use encoding equals UTF-8 when opening JSON file as a text file for both of reading and writing. This simple serialization technique can handle lists and dictionaries, but serializing arbitrary class instances in JSON requires a bit of extra effort. The reference for the JSON module contains an explanation of this. See also Pickle, the Pickle module. Contrary to JSON, Pickle is a protocol which allows the serialization of arbitrarily complex Python objects. As such, it is specific to Python and cannot be used to communicate with applications written in other languages. It is also insecure by default. Deserializing Pickle data coming from an untrusted source can execute arbitrary code if the data was crafted by a skilled attacker. So, careful with pickles.